Hello and good evening and welcome to this channel at the Sam Educators channel. So in this video we'll be having a physics lesson and the topic will be current electricity. So we'll be looking at current electricity. So we'll be looking at direct current. We know we have alternating current and direct current. Direct current is just current in one direction. So before we go in depth into the topic, there are some quantities that we need to understand. There are three basic quantities that we need to understand, which are: the first one is electric current, then after electric current the second one is potential difference, then after potential difference we have electrical resistance. So we have to look at electric current, potential difference, and electrical resistance. So what is electric current? What is electric current? Electric current is the rate of flow of charge round a circuit. The rate of flow of charge round a circuit. Electric current is what? The rate of flow of charge round a circuit. The S1 unit of measurement of charge is coulomb. So electrical current, like I said, is the flow of current, is the flow of charge round a circuit. Is a flow of what? Charge round a circuit, or is a flow of charge per unit time in a circuit. The SI unit of measurement of charge is coulombs. It has a symbol capital C. The SI unit of measurement of charge is coulombs. Coulombs has the symbol of capital C. While current is measured in amperes, amperes is represented by capital A. If a quantity of charge of Q coulombs flows for 2 seconds in a circuit, then the electric current I is going to be equals to Q over T. Q is in A is in amperes I, which is the current, is in amperes A. Then Q is in coulomb C, while time is in seconds S. So we have coulombs per second equals to amperes. The unit of electric current is actually amperes. It is called ampere. So we're going to look at a question right now. So our question states that a quantity of charge of 9 coulombs flows through a wire for 3 seconds. Calculate the current in the wire. So let's write out the parameters that we have. Solution. We have quantity of charge of 9 coulombs. So that is Q equals to 9 coulombs. Then how long did this charge flow? It flowed for 3 seconds. So the time is 3 seconds. What are we going to calculate? The current I. So what's the formula that relates charge to time and current? The formula is I is equals to Q over T. So what is our Q? 9 coulombs. What is our T? 3 seconds. So we have 9 coulombs over 3 seconds. 3 in 9 is what? 3 in 9 is 3. So our current is equals to 3 amperes. So we've solved this question. Now our current is what? 3 amperes. Our question is solved completely. Okay. So this is the solution of the question. So currents can vary from very large values, such as in electric motors, to very small values, such as in transistors, radio, capacitors, and the rest. So when you have small current, you can have smaller units such as milliamperes. That is MA. You can have microamperes, where you have mu A. Milliamperes means 10 raised power minus 3 of an ampere, while microampere stands for 10 raised to power minus 6 of an ampere. So I've talked about electric current, that electric current is measured in what? Amperes. Electric current is basically what? The flow of charge. So we are going to move right away to electric potential difference. Electric potential difference. So we are moving right away to electric potential difference. Electric potential difference. PD. PD is a short form for potential difference. P, potential, D, difference. So what is electric potential difference? Electric potential difference basically is a kind of electric pressure difference between 2 points in an electric circuit. Is a kind of what? Electric pressure difference between 2 points in an electric circuit. Now, when it comes to water flowing from one point to another, water can only flow when there is a pressure difference between the point from which water is flowing to another point. The point from which water is flowing must be at a higher pressure than where it is flowing to. That is why water can easily flow from the top of a building to the bottom, or from a high elevation to a lower one. Why water can flow from a high elevation to the lower one is that the high elevation is at a higher pressure compared to the lower elevation, which is at a lower pressure. So there is a pressure difference. You can subtract the higher pressure at the high elevation minus the low pressure. That gives you a pressure difference. So water can easily flow from up here down here. If you want water to flow from down here up here, it's not going to be possible. For you to achieve that, you need to use a pump. So the pump is going to increase the pressure difference of the water here to be higher than what you have up here. It is only when the pump can supply the pressure difference that is greater than what you have up here that water can now rise from the bottom to the top of a building. So the same in electric circuits. For current to flow from one point in a circuit to another one, the point from which water is current is flowing from must be at a higher electric potential, higher electric pressure. The electric pressure there must be greater than where the current is flowing to. That one must be lower. So that's why we say it's a kind of electric pressure difference. For water to flow, there must be a pressure difference. There must be a pressure difference. For current to flow, there must be an electric pressure difference between 2 points in an electric circuit. Where it is flowing from must be at a higher pressure. It must be at a higher potential compared to where it is flowing to. So current only flows through a wire because there is a potential difference between the ends of the wire. So let's assume this is a wire. This is point A and this is point B. For current to flow from this point A of this wire to this point B, point A must be at a higher potential compared to point B. Point B must be at a lower potential. So when you subtract the potential at A minus B, you get a potential difference. So let's assume now, if B is at a potential difference of 2 volts, then A can be at the potential difference of 5 volts. So at the end of the day, potential difference between A and B is 5 minus 2, which is 3 volts. So the current can now actually flow. So water flows due to a pressure difference between 2 points in a pipe. Current flows due to a potential difference between 2 points in a conductor, in a wire, in any conductor. That is the reason why current flow. If both points, if this point and this point are the same potential, current is not going to flow. If this point is at the higher potential, current will not flow from here to here. Rather, it can flow from here to here. So I hope you've taken notes. So I'm going to give you another definition of potential difference. This is one definition which I've given you. Okay, so I'm going to give you another one, and you need to put these definitions into your head, because when you're writing an objective exam, they can supply you all the definitions and supply you one that is wrong and ask you to pick the wrong one out of the group. Okay, so I'm going to give you another one right now. So the definition we have here for potential difference is the potential difference between 2 points in a circuit is the work done in joules when one coulomb of charge moves from one point to another in that circuit. The potential difference between 2 points in a circuit, potential difference can only occur between 2 points. So the potential difference between 2 points in a circuit is the work done in joules when one coulomb of charge moves from one point to another in that circuit. So this is an alternative definition of potential difference. Now, the SI unit of measurement of potential difference, SI unit is volts. The SI unit is what? Volts. Okay. So the SI unit is volts. Okay. Now we have larger units such as kilovolts. We have larger units such as kilovolts. The kilovolt is 1000 volts. That is 10 raised to power minus 3 volts. Then we have smaller units such as millivolts, which is 10 raised to power minus 3 volts. Now, the potential difference in a circuit is measured with the aid of an instrument called the voltmeter. The voltmeter is an instrument that is used to measure the potential difference between 2 points in an electric circuit. Okay. So the voltmeter is used to measure what? Potential difference. So we didn't measure the instrument that was used to measure current in a circuit. The instrument is called an ammeter. Ammeter. Okay. So next we are going to move to resistance. I've just talked about potential difference, which I believe you actually understand. Now, before I go ahead, if you're not subscribed to this channel, make sure you hit the subscribe button and hit the like button as well, because I know you are actually enjoying this video. Now, materials that allow electricity to flow through them are referred to as conductors, and they can be classified into good conductors and poor conductors or bad conductors. What is the basis of classification into good or bad conductors? The basis of classification is that property called resistance of a conductor. This property is this quantity called resistance is the base of classifying a conductor into either a good conductor or a bad one. Okay, so in electricity, we think in terms of the ability of a substance or material to resist the flow of electric charges, to resist the flow of electricity, to resist the flow of current, to resist the flow of charges flowing through it. So a good conductor has low resistance. A good conductor is a conductor that will easily allow current, easily allow charge, easily allow electricity to flow through it without opposing the current, without trying to oppose. Okay, it will not say current, you're not going to flow through me. It will just allow the current to easily flow through it. While a poor conductor, when current wants to flow, it will oppose. It will not allow the current to readily flow. So it's going to slow down the flow of the current. Current doesn't really flow through a poor conductor. So a poor conductor has a high resistance to flow of current. It has what? A high resistance. A good conductor has a low resistance, very low resistance, while a poor conductor or a bad one has high resistance. So now there are materials that don't allow current to flow through them. They are called insulators. And insulator can be described as having infinite resistance. An insulator can be described as having what? Infinite resistance. No current can pass through an insulator. Now, which is the best conductor? The best conductor in the world is silver. Silver is the best conductor, followed by copper. Silver is the best conductor, followed by copper. But we don't use silver readily because silver is very, very expensive. Copper is cheaper, and copper is equally good, but silver is the best. But silver is expensive. Let's assume now that we have on our roads we had cables made of silver. Easily people go and steal the cables, and so that they can actually sell the cables and make money. So that is why we make use of copper, which is actually also good, although it's not as good as silver, but far cheaper. Okay, so that is the reason why we make use of silver. Okay. In a circuit, when it is desired to have a high resistance, there are special alloys that are used. And examples of these special alloys are Constantine, manganic, and nichrome. These are special alloys that are used to generate high resistance in a circuit. When you need a high resistance, you can make use of this substance, these special alloys. Okay, so now let me even describe a scenario where you can desire high resistance, because you might be thinking, resistance opposes flow of current. Why? As in, can it be advantageous? Yeah, there are instances where resistance can be advantageous. Why? There are times when maybe you on a generator, and when you switch on appliances, it will start blowing the appliances due to supplying the voltage is so high. The voltage that is being supplied. So what you do is that you will look for appliances that can consume large amounts of voltage. Appliances that can actually consume a lot of power to plug in, so that it won't damage your stuff. So when you plug in this appliance, you switch them on, it will consume a lot. So what these appliances are doing is that they are actually offering resistance to the flow of the current. That is what they're actually doing. Okay, so next we are going to move. What is the unit of measuring resistance? The unit of measuring SI unit is called the ohms. OHMS, ohms. The symbol is this symbol, which is called omega. This is a symbol for omega. It's a Greek symbol. So resistance is measured in ohms. This is symbol omega. Okay. So we are going to define the ohms now. So the ohms can be defined as the resistance of a wire if a current of 1 amperes flows through the wire when a potential difference of 1 volt is connected to it. The ohms can be defined as the resistance of a wire or of a conductor if a current of 1 amperes flows through that wire or conductor when a potential difference of 1 volt is connected to it. So this is the definition of the ohms. So we're going to look at another quantity called conductance. A quantity called conductance. Okay, but before we go to conductance, there's a formula that connects potential difference, resistance, and current. That formula is called Ohm's law. V is equals to IR. Although we're going to look at it in detail later on, but I just want to introduce it. V is equals to IR. V is the potential difference, I is the current, R is the resistance. So right now we're going to go into resistance, conductance, not resistance. We're going to look at conductance. So conductance, what is conductance? Conductance can be defined as the inverse or reciprocal of resistance. That means conductance has to do with the ability to conduct. Resistance opposes. Conductance is the inverse or reciprocal of resistance. Conductance is equals to 1 over resistance. The unit of measuring conductance is Siemens. Siemens. Capital S. The symbol is capital S. This is a unit. So we're going to calculate. We're going to do a calculation right now. We are going to solve a calculation. Okay. So in our calculation, the potential difference across a conductor is 3 volts, while the current flowing through the conductor is 0.3 amperes. Calculate the conductance of the conductor. So already we are told that conductance is equal to 1 over resistance. So if we can calculate the resistance of this conductor, we can calculate the conductance. So first of all, we calculate the resistance from Ohm's law. V is equals to IR. V is equals to what? IR in Ohm's law. So from here, R is equals to V over I. From here, you make R the subject of this equation. So R is equals to V over I. Okay. Now, V over R is what? Our V is the potential difference is 3 volts. Our current is what? 0.3 amperes. Okay. So 3 divided by 0.3 is same thing as this is 3.0, same thing as 3.0 divided by 0.3. This is 30 over 3. 3 and 30 is 10. So the resistance here is 10 ohms. But our business is not with the resistance, the conductance. Conductance is equals to 1 over our conductance is 1 over resistance, and the resistance is 10. So 1 over 10. This gives us 0.1. So our conductance is 0.1 Siemens. So first of all, we have to calculate resistance, and then we'll now use it, find the inverse. That gives us the conductance of that conductor. Okay. So in this lesson, we've looked at the basic quantities associated with electricity. We've looked at electric current. We've looked at potential difference, electric potential difference. We've looked at electrical resistance. We've even delved into conductance. So in our next lesson, we are going to go into electric circuits. We are going to commence with electric circuits. So I believe you've enjoyed the video. Now, I believe you've enjoyed the video. So if you're not subscribed, go ahead and subscribe to this channel and click on the like button as well, because you've actually enjoyed the lecture, and drop your comments based on how you've enjoyed the video, or in any way you might want us to improve to serve you better. Drop a comment. So in case you want a one-on-one lecture, you can chat with me via my WhatsApp number, which is displayed there. That is +2348038295185. So thank you so much, and we're going to meet in our next lesson. Bye.